Hi guys, I'm Diaz and you're watching the SUV Battle channel.
I know you love comparisons of different cars on a diagonal suspension that have already become traditional for my channel. But today, I have prepared something interesting for you. Please watch this video until the end, as it is very important for me to know your opinion. Thus, I will understand if such videos would be interesting for you in the future. Well, now that the intro part is over, let's move on to the main characters of this video. There will be 4 of them in total. Mazda CX-5, which has already been on the channel in the winter battle of crossovers. Unfortunately, I couldn't find an updated version. Then, Hyundai Tucson, Toyota RAV4, and Chevrolet Equinox. All of them are equipped with standard gasoline 2-liter engines, except for the Chevrolet. In Kazakhstan, where this video is being shot, Equinox is offered only with a 2-liter gasoline turbo engine, so it has a significant advantage in power. And in addition to the traditional frame twister battles that you are already used to on this channel, today we will measure fuel consumption. For the purity of the experiment, as well as for the result to correspond to real operating conditions, 3 conditions were met. First, all cars arrived with empty fuel tanks at the gas station. Then, from one pump and using the same gas nozzle, a fuel tank of gasoline was poured into each car before automatic fuel cutoff. After driving the entire route, which is about 200 kilometers, we will return to this pump to fill up full tanks again. This method will reveal the amount of fuel actually spent. The next step is adding additional ballast. Each car is loaded with 90 kilograms of cargo in the form of 33 kilogram sandbags. By this, we simulate the presence of passengers in the car. And the third condition is tire pressure. It is set to recommended values. Well, now that all the formalities have been completed, it's time to hit the road. Get comfy, we're getting started. Before driving, we reset the odometer and average fuel consumption values. I wonder what result the onboard computer will show at the end of the experiment and how significant the discrepancy with the actual consumption will be. From the gas station, the convoy heads in the direction of the exit from the city, which is almost 6 kilometers away. Several pedestrian crossings, and 3 traffic lights. After passing the city border, we drive 15 kilometers at a speed of about 100 kilometers per hour, reaching the payment point. And then, we increase the speed to 140 kilometers per hour, a maximum allowed speed for a highway. Taking this opportunity, we will make a so-called 140 challenge. The essence of this challenge is to set 140 kilometers per hour on cruise control and fix at what RPM the engine will run at this speed. Accordingly, the lower the RPM, the lower the fuel consumption. Mazda CX-5 with a 6-speed automatic transmission shows a result of about 2,850 RPM. Hyundai Tucson with a 6-speed automatic transmission goes at 3,000 RPM on the same site at 140 kilometers an hour on cruise control. The Toyota RAV4 of 2021, equipped with a 2-liter engine and a CVT, shows 2,650 revolutions. And the 4th participant, Chevrolet Equinox with a 9-speed automatic transmission, goes at 2,600 revolutions at a speed of 140 kilometers per hour. The result of the 140 challenge? Chevrolet Equinox has the best result. Toyota RAV4 has the 2nd place, Mazda's in 3rd, and the Hyundai Tucson is last on the list. On the way back, moving along the same road section, we will go 100 kilometers per hour and see if there will be a change in the arrangement of participants. Meanwhile, after driving 44 kilometers at a high speed, we reached a small town, which means we are slowing down. There are 15 kilometers ahead, where participants will have to make 7 turns, drive 12 traffic lights, cross 23 pedestrian crossings, overcome 10 speed bumps, and even railway tracks. It's a pity that a small city can't boast of traffic density on a weekend, but ahead we will still have sections with busy traffic at low speed. After leaving the city, we drive 1 kilometer through the town where we also face pedestrian crossings and speed bumps, one of which is especially high, forcing drivers to significantly slow down. At the 75th kilometer from the start, the column moves onto a dirt road with a lot of dust, and after a while, reaches a small rise with diagonal suspension. And obviously, we couldn't pass by. According to the comments below the previous video with the Mazda CX-5, in order to conquer this diagonal suspension, it is necessary to turn off the ESP and switch the gearbox to manual mode, limiting it to the first gear. After the driver completes these actions, he starts moving. The front left and rear right wheels of Mazda have tight support. The front right is hanging in the air, and only the rear left clinging to the ground is trying to push the car forward. We make one more attempt. Two wheels are clinging to the ground, but the result is unchanged. And even the change of trajectory did not play a significant role. Mazda is stalling with its wheels hanging out without a hint of forward movement. Therefore, we roll back to the area where the three wheels are firmly on the ground. Taking a little to the right to avoid a particularly strong diagonal, Mazda moves forward, skids throwing stones out from under the wheels, and completes the conquest of this obstacle. Let me remind you once again that this diagonal hanging is a random obstacle that got in the way. The main and more difficult test will be ahead, and we have not reached it yet. Next, Hyundai Tucson. The car reaches the same point where the Mazda has just been helplessly skidding. The unloaded wheels slip until the traction control system is activated, after which it is clearly visible how they are blocked until a complete stop when the Tucson catches the balance and hangs in the air, relying only on two diagonally positioned wheels. As a result, a confident finish along a difficult trajectory. The next in line is Toyota RAV4. The car reaches the fixation point, stops, and the driver smoothly starts raising the engine revolutions. It is clearly visible how the wheels slow down during the operation of the traction control system. But even after a long slip, RAV4 could not conquer the climb. In the next step, we activate the rock and dirt mode. The rotation of the wheels has become less intense. You can hear that the engine is running under load, and the car is moving forward, even being on three wheels. An excellent result, considering that the previous generation RAV4, even in simpler conditions, is absolutely helpless. You can see more details in the winter battle of crossovers at the link in the description. And finally, the fourth participant, Chevrolet Equinox with a powerful 2-liter turbo engine. The car reaches the fixing point. The engine is running, the hanging wheels are slipping, but the Chevrolet is standing still. Let's turn up the wick and keep the revs longer. Chevrolet coped well with this obstacle, the sufficient power reserve effects. But the operation of the traction control system could be more efficient. But let's not rush to conclusions because we have a major obstacle ahead. And then the whole convoy drives along windy dirt roads for many kilometers. When the odometer showed almost 100 kilometers, we reached the filming location of the Battle of the Titans and medium-sized SUVs. For links to both of these videos, see the description. Given that the obstacles in this section do not correspond to the class of our cars, we will not stay long at this place. We descend from the mountain and make a big detour to return to the dirt road leading to the destination. It's already 115 kilometers on the odometer, and a group of cars has arrived at the place of the main obstacle. We will not specifically turn off the engines throughout the entire stop, which is about 1 hour to simulate being in traffic jams when the engine is idling for a long time. Taking this opportunity, let's see what information the onboard computers give out. The average fuel consumption of the Mazda CX-5 is 10 1/10 of a liter. Hyundai Tucson has a slightly better result, 9.8. Toyota RAV4 sets a new bar at 9.2, and the most powerful of the four, Chevrolet Equinox, demonstrates the best appetite, 10 8/10 of a liter. Now I'll tell you about the obstacle. The ascent consists of two parts. First, the participants are met by rock, and then they'll need to overcome the diagonal suspension test. And all of this with a good slope. Taking into account the design features of the participants of this test, we will pass the first part along a simple trajectory. We will leave the difficult one for cars with a large margin of power. Mazda starts first. The gearbox is in first gear and the ESP system is disabled. The car reaches the fixing point. Giving it some gas, a slight slip, and Mazda goes forward. It's a good start. And here's the most interesting part. Mazda will definitely suffer here. The unloaded wheels rotate, but this is not enough to cope with this obstacle. It may seem that Mazda is about to conquer the ascent, but look at the rear right wheel. It is clamped as much as possible into the arc, which means it is experiencing the greatest load. As a result, slipping to smoke from the friction of tires on stones, the all-wheel drive clutch overheats and the rear axle left the chat. After taking a short pause to cool down, we roll back to pass this obstacle. Although not safe, but in the only possible way, by taking a good acceleration. The next participant is Hyundai Tucson. The gearbox is in the drive position and we start moving. We reach the fixing point and, slipping the wheels out, the Tucson sticks in place. It's strange how Mazda managed to easily pass this place. Write your opinion in the comments while Hyundai rolls back to change the trajectory. Tucson accelerates, slipping before the start of the traction control system and slowing down the posted wheels. Tucson coped with the first part. Pay attention to the rotation of the loaded left front wheel, which indicates the effectiveness of the traction control system. It is due to this that the Tucson, although it shifts to the right, still moves forward and finishes safely after overcoming this climb with difficulty. The next participant is a Toyota RAV4 with a 2-liter gasoline engine. The car is equipped with a CVT, but the first gear is mechanical. Also, this RAV4 has a new all-wheel drive with 2 additional clutches on the rear axle. I wonder how this set will show itself on the most difficult obstacle. The gearbox is in the drive position. Rock and dirt mode is activated. Toyota reaches the same place where Tucson was stuck before. You can hear the engine running under load, but none of the wheels are rotating. Without changing the position of the car, we transfer the transmission to first gear. The mode is still rock and dirt. Just like the Hyundai Tucson, the Toyota RAV4 stands still with unloaded wheels. The engine power is not enough to ensure forward movement. And this experiment also showed the benefits of switching from drive mode to first gear. In certain situations, it will help to conquer an obstacle. Well, in our case, we roll back a little bit to take a right and drive along a simpler trajectory. At the finish of the first section, RAV4 found another improvised frame twister, and it is clearly visible how the unloaded wheels are clamped, ensuring forward movement. The main thing is to have enough engine power. We reach the final obstacle without changing the settings. Make a full stop and there is just not enough engine power. The traction control system clamps the suspended wheels, but the loaded wheel does not have enough torque to scroll and go forward. We turn off the ESP system to see what the behavior of the car will be in these conditions, which is to be expected. Disabling the ESP system will allow us to pass the obstacle using the momentum without limiting the engine speed during slipping. Sometimes this is the only possible way to overcome the obstacle. We turn ESP back on and roll back to slightly change the trajectory. RAV4 drifts to the right, and it seems that the car is about to conquer the rise. And look how tightly the rear right wheel sits in the arc. Rolling back a little bit to the place where the front right wheel has gotten sufficient support, Toyota starts moving and safely completes the race. And the most powerful participant of this test is Chevrolet Equinox. Now we will find out whether a larger margin of torque will be a clear advantage on this climb. Chevrolet takes a good acceleration and passes the fixation point where the Tucson and RAV4 stopped before. Therefore, we roll back so that the passages are as identical as possible. A slight slip at the very beginning, and then a confident movement forward. Even stopping with two wheels in the air where the RAV4 had to strain to get out. Equinox briefly skidded, but then immediately continued to move on. We make a full stop once we reach the main obstacle. The unloaded wheels are slipping, but the car is standing still. Another attempt at a smooth acceleration, but the result is still the same. Now, we will accelerate a bit more, and we will keep the revs longer. That's what a sufficient supply of torque means. Equinox shot forward like a bullet, as if there was no obstacle at all.
And before we go any further, the traditional arrangement of places.
Mazda CX-5 was expected to show the worst result. Inefficient operation of the traction control system and rapid overheating of the clutch. We have seen all this in previous compact SUV battles. Moreover, even with a more powerful 2.5 gasoline engine, the Mazda crossover behaves exactly the same. For more information, watch the Battle of Crossovers 2020 video. The link is in the description. I wonder what the behavior of the updated CX-5 with off-road mode will be. I will definitely check it when the car is available at dealerships. Toyota RAV4 is in third place. The presence of off-road mode and two clutches on the rear axle, of course, have a positive effect on the capabilities of the car. But in particularly difficult conditions, there is clearly not enough engine power. The system protects the CVT, forcibly limiting the amount of torque. The second place is for Hyundai Tucson. It doesn't have off-road modes and additional clutches, but it does have a regular automatic transmission that digests more power. This is probably why Tucson could scroll the hanged wheels on the first part of the obstacle, unlike the RAV4, and also coped with the most difficult obstacle without having to roll back. And the first place goes to Chevrolet Equinox. A powerful engine and a fairly efficient traction control system together are an excellent tandem. That is why Equinox easily passed all the tests, and the only question was the intensity of pressing the gas pedal. You have the right to be outraged. Like, the test is not honest because Chevrolet has a clear power advantage. But as I said at the very beginning, I took popular crossovers with standard engines. And in this case of the Chevrolet Equinox 2.0 Turbo, this is the only engine available for this crossover in Kazakhstan. On this wonderful note, our convoy set off on its way back, to arrive at the same gas station from where today's journey began. After driving for 3 kilometers on a dirt road, we finally hit asphalt. Further driving through the town, we returned to the main highway again, in the part where it passes through the city. Therefore, the speed of movement is not more than 60 kilometers per hour. Having passed the border of the city at around 132 kilometers on the odometer, we have to drive 55 kilometers in highway mode. We will drive at a speed of 100 kilometers per hour on cruise control, simulating traffic on ordinary two-lane roads. Under these conditions, the Mazda CX-5 engine RPM barely exceeds 2,000. Hyundai Tucson has about the same situation. The RPM is slightly higher than 2,000. But Toyota RAV4 surprises with its 1,500 RPM. And the Chevrolet Equinox has revs just below 2,000 due to the 9-speed gearbox. At a speed of 140 kilometers per hour, the difference in RPMs was more significant. There are 185 kilometers on the odometer already, which means there are about 5 kilometers left to the gas station, 3 traffic lights, and several pedestrian crossings. The Mazda CX-5 is refueled first, and the refueling gun clicks off at the 15.2-liter mark. Next, Hyundai Tucson. The counter stops at 18.08. The third car is the Toyota RAV4 with a score of 15.42 liters. And the Chevrolet Equinox completes the list with an impressive 19.8 liters. What will be the final fuel consumption per 100 kilometers? I made the calculation based on the odometer readings of each car. A special emphasis on this since the difference in the distance traveled was almost 10 kilometers or 5%. Although all the cars went in one column and were always there. The biggest fuel guzzler car was the most powerful participant of this test. Chevy Equinox. It consumed 10.33 liters to overcome 100 kilometers in a mixed cycle. In third place, Hyundai Tucson with a 2-liter naturally aspirated gasoline engine and a 6-speed automatic transmission. Its consumption per 100 kilometers was 9.34 liters. In second place is the Toyota RAV4 with a 2-liter gasoline engine and a CVT. Fuel consumption per 100 kilometers turned out to be 8.42 liters. And the first place goes to the Mazda CX-5, which showed the worst result off-road, but became the champion in the economy stage. Its average fuel consumption per 100 kilometers in a mixed cycle with a ballast of 90 kilograms was 8.5 liters. However, according to the data of the onboard computers, Mazda has an average fuel consumption of 10.1, Hyundai has 9.1, Toyota has 8.7, and Chevrolet has 10.1 liters. If we transfer the results obtained to a mileage of 15,000 kilometers, then Mazda CX-5 will need almost 1,200 liters, RAV4 1,260, Hyundai Tucson 1,400, and the Chevrolet Equinox 1,550 liters.
That's all for today's test. Let me know which car surprised you the most and which one was a disappointment. And also don't forget to share your opinion about this experimental format. I'm Diaz, see you in the next video.